Alright, so what I want you to notice is that you got the same answer regardless of which method you chose. And what you did is you really saved yourself this process of having to reduce that you had to do using that first method. And the reason why is because you're choosing to multiply each fraction using smaller numbers. Okay, so then in the end, we don't have to reduce again. So we're just really saving ourselves some work simply by finding the common multiple. Okay, but either method works. Alright, you guys, so now we're going to talk about what happens when we add and subtract fractions with mixed numbers like these guys here. So mixed number again is when we have a whole number with a fraction. So process number 1, and on your sheet, if you're following along with this worksheet, I also have process number 2 that I'm not going to talk about. Well, I'll show you in one example how you can use that process, but for the most part, process number 1 is the best. Okay, so I'm going to try to keep things simpler for you today. So this process number 1, use improper fractions. Okay, so it's okay, again, we prefer improper fractions. That's what we're going to do. So we're going to change each we're going to change each mixed number into an improper fraction. And again, remember when I said we prefer improper fractions? Well, this is why, because a lot of times we have to change it anyways. So in order to do that, here's your notes. We're going to multiply the number by the denominator, then add to the numerator. So let's look at this first example. To change this mixed number into an improper fraction, we're going to take that denominator, multiply it by the whole number 2, and add that amount to the numerator. So 3 times 2 is 6, plus 1 is 7. So this is the same thing as 7/3. Again, same process here. 4 times 3 is 12, plus 1 is 13, plus 13/4. Alright, so what I want you to notice next is that, again, we do not have common denominators. That's a requirement to add these fractions. So what do we have to do? We have to follow these steps of what we do when we do not have with different denominators, okay? So going back here, how do I make these a common denominator? Well, I can multiply 3 times 4 is 12, so I want the common denominator to be 12. What do I do to 3 to get to 12? Multiply by 4, which you do in the denominator, you have to do in the numerator. 7 times 4 is 28. Okay, how do I get from 4 to 12? Well, I multiply by 3. I tripled this fraction, so I have to do that in my numerator too. 3 times 13 is 39. Now I can add my fractions. 28 plus 39 is 67/12. Alright, the question is, can I reduce this fraction? No, you may not. So that's going to be your final answer. Again, you could change it into a mixed number if you want, but sometimes that's going to cause you more work. So just keep it as an improper fraction. Alright, well, let's look at this problem. So using the same process again, and I actually encourage you to pause the video, try it on your own, and see if you got the same answer. But again, we're going to convert this mixed number into an improper fraction. 5 times 4 is 20, plus 3 is 23/5. Okay, 3 times 2 is 6, plus 2 is 8/3. Okay, now again we need that common denominator. So I think, what is the least common multiple? Well, if I go count by 5s, I get 5, 10, 15. If I count by 3s, I get 3, 6, 9, 12, 15. So 15 is our least common multiple. So that's what the number in our denominator will be. How did I go from 5 to 15? I multiplied by 3, so we're going to also do that in our numerator. 3 times 23 is 69. How do I go from 3 to 15? Multiply by 5, so I'm going to do that in the numerator. 8 times 5 is 40. Alright, so this I can also write as 69 over 4 plus 40 over 15, because again the denominator is going to stay the same. 69 plus 40, that's 109 over 15 android. Okay, again you can actually not reduce that fraction. Okay, and this last one, let's say if you were trying to do this method, because I see this a lot. We're going to try to subtract these, and I'm going to rewrite this. Okay, so now these are written vertically, one on top of the other. What we could do is you could subtract the fractions. 1/4 minus 3/4. So technically what we're doing here is, again, when we subtract fractions, 1/4 minus 3/4, the denominator is going to stay the same. That's 4. 1 minus 3 is, well, that's -2. Okay, be careful with those integers. Well, I don't like the number -2. That's kind of weird. So what I'm going to do is, I don't like negative fractions. I'm going to actually borrow a whole number here. So I'm going to make that a 3. And so that means I have a whole that I'm borrowing. In that whole, there's 4 parts, right? So this is actually going to be 1, 2, 3, 4, 5. So now that's, I've made this into 5/4. And I could just rewrite this as 3 and 5/4. Now I can take 5/4 minus 3/4 is 2/4. 5 minus 3 is 2. Okay, so 2/4. And now I can go 3 minus 1 is 2. And then I can reduce this fraction still. That's 2 and 1/2. So that's another process I could have done. I call that process number 2 in these guided notes. Now, usually it's more difficult. So another way you could have solved the problem is convert each of those fractions into improper fractions, like I solved these first 2 problems. But I just wanted to let you know that this is another method you can absolutely use. Alright, you guys, that is all the notes I have for you. You just have a few more practice problems to do from that worksheet. So go ahead and do this now.